Howdy, folks. This is a video for you with some sample free response questions for descriptive statistics. Okay, I've got two problems in here on different aspects of descriptive stats. So let's just go ahead and jump right into it. One thing that I will say about descriptive statistics in sample, like in FRQs, is that a lot of the time, this will be integrated with another type of free response question. Like you'll have to do one part of the question that'll be about descriptive statistics, and then the other part will be related to something else, like inference or a probability or something like that. Okay, so in this first question, which is from the 2000 test, it's the third question on the 2000 test. Okay, essentially what they did is they did this study where they randomly selected a bunch of middle-aged men and young adult men and then asked them to rate themselves on a scale from 1 to 10 on their physical flexibility, where 1 was the lowest and 10 was the highest. Okay, and all that is given to you is this frequency table below. Okay, and then they give you an example of like how to read it. So 17 middle-aged men had a flexibility rating of 1. 4 young adult men had a flexibility rating of 1, for example. Okay. So part A says to display these data graphically so that it's easy to compare the two groups. Okay. So whenever they're talking about wanting to do something that's easily comparable, my advice would be to either do a histogram comparison or a box plot comparison. So I actually did a histogram comparison a couple of different ways using some technology. So give me a second. I have to pause the video so that I can insert those pictures, and then I'll kind of talk you through how I made them and why I made them this way. So I'll see you in just a second. Okay, so here are my graphical data. My graphical displays. I did two different options for you here. So the one at the top without the color is just two histograms, like side by side, which is the most common option, what I would recommend that you do. Okay, so essentially what I did is I have their flexibility rating as my x-axis, your frequency, meaning the number that fit at that particular flexibility rating, is your y-axis, right? And then you just kind of have to sketch like approximately how tall each of these bars, each of these bins is going to be. And then just for ease of comparison, I labeled at the top of each bin with the actual frequency in each one. Okay, so this is the one for the middle-aged men, and then this is the one on the right for the young men, right? And doing this way, it's very easy to compare the two. Even just visually looking at them, they're obviously very different in their shape. And then because of that, they'll be different in their center as well, and possibly their IQR. Right? Okay, so another way that you could do this would be like a side-by-side histogram, which is what this is. I wouldn't recommend that you do this way just because it almost looks like a bar graph when you do it this way, and it's not a bar graph. Like it should be a histogram. Okay, so just the way that this was, like the way that the software created this, it almost like it separated the bins so that it looks more like a bar graph than a histogram. Really, realistically, there shouldn't be any space between these bars. Okay, and then there's a key, obviously, and then it's color coded so you can kind of see the changes in the shape. Okay, all right. So those are your graphical displays. You could have also done it with a box plot, but that would take a little while. So I would recommend you do a histogram just because of the way that the data is presented to you there. Okay. All right, so then part B says, based on an examination, write a few sentences comparing the flexibility. Okay, so whenever we're talking about comparing, you're talking about your 4 things, right? Your cuss and BS. So center the unusual, shape, and spread. Okay, so let's just go down one by one and talk about them. Okay. Okay, so for center, you just kind of want to estimate where the median is. And I would say the median is probably between 5 and 6. So you can just round and say approximately 5.5. So, and then for the young adult men, I would say the median is definitely larger. Okay, the mean is smaller, but the median is definitely larger. So I would say it's probably between 6 and 7, right? So remember, we have to identify what the individual centers are and then use comparative language to compare them. Okay, so you would say something along the lines of the center, and then note that you're using the median of young men and rather I should say of the flexibility rating of young men is approximately 6.5, which is higher than the median flexibility rating of middle-aged men, which is approximately, and then that approximately 5.5. Okay, that's all you have to write. Okay, notice I've used my comparative language and I've stated each of my medians. Okay, U is the unusual. I don't see any gaps or outliers here. So you would just say neither distribution has apparent, so that would be great, gaps or outliers. Okay. These in parentheses for you so that you don't have to write what each of these are, but I'm just writing it for you so you can kind of see. So center unusual, next comes shape. Okay, so I would say that the middle-aged men distribution is approximately symmetric, while the young men is definitely skewed to the left, right? Definitely skewed to the left. So you would say the distribution of flexibility rating of young men is skewed left, while the distribution of flexibility rating of middle-aged men is approximately symmetric. All right, and then last is talking about spread. Okay. Okay. So here they have the same range, right? They have the same range, and so you may want to look at IQR, but I'm pretty sure that the IQR will be the same for both of these as well. So you just kind of want to talk about that briefly and say that that the range and IQR are equal for both distributions of flexibility ratings. Okay, and then you may want to say something along the lines of while there was large variability in both distributions, there were more young men on the higher end of the flexibility rating scale than the middle-aged men. Okay, you could have also said there were less young men on the lower end when compared to middle-aged men. Okay, so there is your comparison. Right? So give me a second. I have to clear my screen off and kind of fix some formatting, and then I'll see you back here in just a moment for the second FRQ. All right, folks, welcome back for your second FRQ. Okay, so I'm gonna start this one by saying this is a classic example of way too much information at the start. Okay, so this is the kind of problem where I would skim over all of this, the background information, and then just to get an idea, just to get an idea of what's going on, and then go straight to the actual questions to see if you can answer any of those quickly without having to gain a bunch of information from the paragraphs, because really you don't need that much of the information in here. Okay, essentially what this problem is about is two gasoline additives. So this experiment, this study is testing the performance of the gasoline in different cars using one of these additives, right? Because they think that it's going to increase gas mileage. Okay, and they just kind of described how they did this study, right? But one important thing that you probably should note is what the negative values mean. Okay, so negative values mean that the distance traveled was less with the additive than without, right? So it actually lowered the gas mileage of that car in that case rather than raising it, okay? All right, and what's lovely is they give you all of the summary statistics. Super, super helpful, okay? Because what they want you to do now is they want you to create box plots, okay? And then notice that they say show any outliers if you see them, okay? So the best thing to do is start with the three numbers in the middle. So your quartile 1, your median, and quartile 3. Okay, so I'm going to put additive A here, and I'm going to put additive B here. Okay, so this is my median for A is 3, which is approximately right here. My quartile 1 is 1, which is approximately right here. And my quartile 3 is 4, which is approximately right here. So draw your box first. Okay, and then go on to your whiskers. Now, I'm actually not going to draw my whiskers yet because I need to determine if any of these values, the ones that say values below quartile 1 and the values above quartile 3, I need to determine if they are outliers or not. Okay, so remember the rule is to figure out outliers, you do Q3 plus 1.5 times the IQR. Okay, and for lower outliers, you do Q1 minus 1.5 times your IQR. Okay, right, 1 second. For some reason, this is cutting my stuff off, and I'm not exactly sure why. Okay, so before we can do anything, we need to figure out what 1.5 times the IQR is. So the IQR for A is 4 minus 1, which is 3. Right, we're doing Q3 minus Q1. So 4 minus 1, which is 3. Okay, and then I'm going to also do the same thing for B, since I have it right here. So for B, the IQR is 25 minus -2, which is 27. Okay, so I'm going to do my my 1.5 times IQR. So for A, 1.5 times 3 is 4.5. So my lower outliers would be 1 minus 4.5. That's my cutoff point, which is negative 3.5. Okay, so anything below negative 3.5 is an outlier. Okay, so meaning that this value, negative 10 and negative 8, are both outliers. So what I'm going to do is I'm going to put a dot to represent those outliers. So negative 10 and negative 8. Right, and then the next highest value is negative 2. So that's where my whisker would start. Okay, the purpose of this is so that you can actually see like the gaps and the outliers that show up. Okay, now for my upper outlier, right, that would be quartile 3, which is 4, plus 1.5 times IQR, which is 4.5. So that's positive 8.5. So any number above 8.5 is an outlier. And so 9 is an outlier. So I'm going to put a little dot for 9, and then my next highest number is 7. So that is where my tail would start. Okay, so that is your box plot for additive A. Right? For additive B, I'm going to kind of work the stuff out down here. So this is not the answer, obviously, to part B. I'm running out of space to work so that you can. I zoomed in a little too much so you guys would actually be able to see what I was doing. Okay, so let's look at additive B. Okay, so additive B, I have my quartile 1, my median, and quartile 3. So my median is 1, so that goes right here-ish. My quartile 1 is negative 2, which is approximately right there. And then quartile 3 is 25, way up here. Okay. I probably will not draw a straight line here, but I'm doing my best. Okay, so there's my IQR. Okay, and then I need to figure out my cutoffs for outliers. Okay, so I have to figure out, so 1.5 times the IQR, which is 27, is 40.5. Okay, so my lower cutoff is Q3, which is 25. Oh, sorry. My lower cutoff, I'm over here losing my marbles. What I was just talking about was the upper, apologies. Okay, so my lower is negative 2 minus 1.5 times IQR, which is 40.5. So when you actually subtract those, you get negative 42.5, which I don't have any values below, right? My lowest value is negative 5. So I can just go to negative 5, that's my lowest value, and draw my whisker in. Okay, so there's no outliers, no lower outliers. For your upper outliers, okay, that would be Q3, which is 25 plus 1.5 times IQR, 40.5. Okay, so that is 65.5. So again, my largest number is 40, so that means I have no upper outliers either. So I'm going to go up to the largest number, which is 40, start there, and draw my whisker going back. So that's part A. Those are your 2 parallel box plots. All right. So give me just a second. I need to clear the screen off a little bit so that I can actually answer part B. So give me one sec. I'm going to clear that off, and I will see you back here momentarily. All right, folks, so part B is saying that there's 2 ways that they're evaluating the effectiveness of this gas additive. They're trying to decide which they should use. Okay, so they're saying either we're going to use the proportion of cars that have increased the gas mileage, okay, meaning that the data shows that they're above 0, okay? Or the mean increase in gas mileage, okay? So for I, right, this first little part here, it's asking which of the additives, A or B, would you recommend if the goal is to increase gas mileage in the highest proportion of cars? Okay, proportion is the key word there. Okay, so if we look at our two additives, right, and the box plots for them, what we want is we want the highest percentage of the data above 0. Okay. And that happened in additive A. Okay. I want the highest percentage to be above 0, right? So here's like my cutoff, right, for evaluating this. Okay. And what we can see is that more than 75%, right? This is 75% of the data. So more than 75% had an increase in gas mileage for A, right? Whereas for B, you only have about 50%, right? Even though it spreads much wider, even though the spread is much wider, that doesn't matter, right, for percentage, right? Because remember, each of these little portions of the box plot represents 25% of the data, right? This whisker is 25% of the data. This part of this box is 25%. This part of the box is 25%, and this whisker is 25%. So here I have 3 of my areas, right? 3 of my separate parts of the box plot above the 0 line. Okay, so additive A is better when you're talking about increasing gas mileage in the highest proportion of cars. Okay, so the way that I would write this is I would say additive A is better at increasing gas mileage in the highest proportion of cars. Okay, and then you would just talk about your percentages, like the ones that I have marked in pink up on the parallel box plots up there. Okay, so the mileage increased for at least 75% of cars with additive A, whereas the mileage only increased for approximately 50% of the cars with additive B. Okay, and that's all you have to write. All right, so that second question here, so hint for you, if your answer to the first was one additive, the answer to the second is likely going to be the other additive. Okay, so this is asking which would you recommend if the goal is to increase gas mileage in the highest, is to increase gas mileage with the highest mean. Like you want to increase the mean the most. Okay, so in that case, you would definitely pick additive B. Okay, additive B is very highly skewed, and it is highly skewed to the right. Okay, which you can kind of see, right? B is definitely skewed right. Okay, which means the mean, the average will be up here somewhere, right? Will likely be maybe around here or somewhere close to that. The average is probably around that point. Okay, the average for for additive A is probably, it may be a little bit lower than the median, but this is approximately symmetric. So I would say it's probably about equal to the median. So you have a much higher average in additive B. Okay, and that's kind of what you want to talk about here. Okay, so if I was to actually type this out, I would say that additive B appears to produce a higher mean mileage gain than additive A. I don't know why I capitalized additive. Okay, and then you want to talk about the skew. So the box plot for additive B shows that the distribution of mileage differences is skewed to the right. This will pull the, oops, struggling with my grammar here. This will pull the average towards the larger values. The mean will be much greater than the median, which you could say which equals 1. Okay. And then you would want to talk about how in additive A, the median is probably equal to the mean, or maybe the mean might be a little bit less. So in additive A, the distribution of mileage differences is approximately symmetric. You could say, or possibly slightly skewed left. Okay. This means that the average mileage will be equal to the median, which was equal to 3, I believe, or possibly lower. Okay, so I know this was longer. This explanation was definitely longer than the than this first part, right? So essentially, you just have to talk about when you're scoring this, right? What they were looking for when scoring was that you had to choose the correct additive, okay, and then explain, talking about both distributions, right? So you had to compare these two, right? Same thing for part I right here, right? Notice that I compared, right, both additive A and additive B in both cases, right? So you really couldn't have just talked about additive B. You had to also talk about why it was better, or why the average was higher for additive B than it was for additive A. Right, using that comparison and using that comparative language. All right, y'all, so I hope that this was helpful for you in looking at how to answer these sample FRQs. I'll see you in the next video. Bye, y'all.